Iceland is burning, slowly, relentlessly, and on a scale few places on Earth can match. Earthquake swarms ripple beneath the surface. Volcanoes crack open without warning. Towers of lava shoot hundreds of meters into the sky. This isn't a single disaster or a short-lived crisis. It's the return of a deep geological rhythm that has shaped this land for over 1,000 years. What we're witnessing today is the reawakening of a cycle that last dominated Iceland when Vikings first arrived on its shores. Back then, nature dictated survival. Now, the timeline is far more unsettling. Scientists believe this phase of activity could continue not for decades, but for 2 to 4 centuries. This is not a spike, it's a marathon of fire. But Iceland today is not an isolated medieval settlement. It is a modern nation built by engineers, monitored by geologists, and defended by data. As the ground splits open and lava threatens towns, roads, and infrastructure, Icelanders are doing something unprecedented, attempting to out-engineer a planet literally tearing itself apart. The question is no longer whether eruptions will happen, but whether a modern society can adapt fast enough to live alongside them for generations. Iceland's story begins deep beneath the Atlantic. The island sits directly atop the mid-Atlantic ridge, where the North American and Eurasian tectonic plates drift apart by about 2 centimeters every year, roughly the speed your fingernails grow. As the plates separate, magma rises, cools, and hardens into basalt, creating brand new Earth. This slow, invisible process has built the longest mountain range on the planet, over 16,000 kilometers long, almost entirely hidden beneath the ocean. Iceland is one of the few places where this colossal engine of planet building breaks the surface, exposing Earth in the act of being born. Fire and ice, creation and destruction. Iceland stands at the front line of them all. That endless underwater mountain chain remains hidden until Iceland breaks the surface. This island exists for one extraordinary reason. It doesn't just sit on a tectonic boundary. It sits on a collision of forces. Beneath Iceland, the mid-Atlantic ridge intersects a deep mantle hotspot, a rare and powerful geological engine. Hotspots usually form island chains like Hawaii or the Galapagos, far from plate edges. Iceland is different. Here, a hotspot and a separating plate boundary stack their effects, turning an already unstable zone into one of the most volcanically productive regions on Earth. The result is staggering. Despite its small size, Iceland has produced nearly a third of all lava erupted on the planet in the last 500 years. That's not because it erupts more often, but because when it does, it erupts big. Hotspots themselves remain one of geology's great mysteries. What scientists do know is that they are driven by columns of abnormally hot rock rising from deep within the Earth. These plumes can persist for tens of millions of years, superheating the mantle by up to 200 degrees Celsius. As pressure drops, solid rock melts into magma, feeding the surface relentlessly. This extra heat thickens Iceland's crust to nearly 40 kilometers, almost 6 times thicker than normal oceanic crust. That thickness gives the land enough buoyancy to rise above the sea, lifting a mid-ocean ridge into daylight. Iceland is the only inhabited place on Earth where you can walk across a plate boundary exposed on land, literally standing between continents. But this is an ancient history. Iceland is geologically young, almost adolescent. Its oldest rocks are just 16 to 18 million years old, while much of Europe sits on crust hundreds of millions of years older. Move south, and the land gets younger still, only 3 to 7 million years old in places like the Reykjanes Peninsula. And just offshore lies something even more unsettling. The youngest land on Earth, still forming, still rising, and still unstable. This is tectonics in real time, and Iceland is living on top of it. In the 1960s, a brand new island burst from the Atlantic Ocean just south of Iceland. Born entirely from lava, it offered scientists something almost unheard of, a landscape with a known birthday. Completely sterile at first and strictly protected from human interference, this island became a living experiment, allowing researchers to watch life build an ecosystem from nothing, step by step, much like the earliest chapters of life on Earth. But Iceland's geological youth is more than a scientific curiosity. It is a serious hazard. Young land means fresh magma, and Iceland has plenty of it. Around 30 active volcanic systems stretch across the island, with more than 100 eruptions in just the last 10,000 years. These systems don't follow tidy rules. Some are centered on volcanoes. Others are vast underground fissure networks, constantly switching on and off over centuries. Because Iceland sits on a rare tectonic sweet spot, it showcases nearly every type of volcanic behavior on the planet, from gentle lava floods to explosive ash-producing eruptions. This fiery reputation has shaped Iceland's identity, but geography forces most people into a narrow strip of land. The frozen interior is largely uninhabitable, so nearly 80% of the population lives near the southwest coast, close to Reykjavik. Here, Icelanders have learned to work with the fire. Over 85% of homes are heated using geothermal energy, turning volcanic heat into a national strength. But concentration brings risk. More people and infrastructure now sit directly in eruption zones. That danger became real in late 2019, when intense earthquake swarms shook the Reykjanes Peninsula. By 2021, magma broke through the surface for the first time in 800 years. More eruptions followed, migrating closer to populated areas. In November 2023, the town of Grindavik was evacuated as magma tore beneath it, destroying homes and infrastructure. For scientists, this wasn't an isolated event. Ancient Viking records and modern ash analysis tell the same story. Reykjanes operates in centuries-long eruptive cycles, and this one has just begun. The difference now? Iceland isn't waiting helplessly. Using satellites, seismic data, and real-time modeling, what began as improvised field experiments quickly evolved into the most ambitious lava defense effort ever attempted. As eruptions crept closer to towns on the Reykjanes Peninsula, Iceland had no choice but to escalate. Today, massive lava barriers stretch for kilometers across the landscape, some rising more than 20 meters high. Their scale is so vast that entirely new quarries were opened just to supply enough material. These defenses are not simple walls. They are carefully engineered structures built from compacted basalt gravel, armored with boulders, and shaped using advanced lava flow models. Their goal isn't to stop lava, an impossible task, but to slow it, redirect it, and protect what matters most: towns, roads, pipelines, and critical infrastructure like geothermal power stations. The system is flexible by design. Strategic gaps allow roads and pipelines to function, but each opening can be sealed within hours if an eruption begins. Behind the scenes, engineers and scientists operate on near-constant alert. When seismic swarms signal magma movement, they may have only minutes to analyze incoming data, predict lava paths, and decide which defenses to activate. So far, the results have been remarkable. The models have proven highly accurate, and barriers have repeatedly done their job. But hard choices are unavoidable. In late 2024, lava overwhelmed areas near the Blue Lagoon. Not because the defenses failed, but because priorities were clear. Power and public safety came first. Parking lots did not. Still, no barrier can save a town if a fissure opens directly beneath it. Recognizing this, Iceland is planning far beyond walls, relocating infrastructure, redesigning roads, burying pipelines deeper, and using AI to refine eruption forecasts. The world is watching closely. Never before has a modern nation tried to engineer its way through a centuries-long volcanic cycle in real time. Beneath Iceland, a geological drama unfolds that has been millions of years in the making. Mantle hotspots, columns of intensely hot, buoyant rock rising from deep within the earth, heat the crust by as much as 200 degrees Celsius. The resulting drop in pressure melts rock into magma, building unusually thick crusts up to 40 kilometers deep. This is why Iceland rises above the Atlantic, forming the only inhabited mid-ocean ridge on the planet. Step into Thingvellir National Park, and you can literally stand between two continents. Yet Iceland's youth is its danger. The oldest rocks are only 16 to 18 million years old, mere infants compared to Europe's half-billion-year crust. Moving south, land gets even younger, and just off the coast, islands like Surtsey, born in the 1960s, provides scientists a rare chance to witness life colonize sterile lava. But young land means molten risk. About 30 volcanic systems crisscross the island, producing every type of eruption imaginable, from shield volcanoes to explosive calderas. Nearly 80% of Iceland's population lives on the relatively mild southwest coast, where geothermal energy heats homes and streets. Concentration brings convenience and exposure. In late 2019, earthquakes under the Reykjanes Peninsula signaled trouble. By 2021, magma broke through for the first time in 8 centuries, beginning a series of eruptions that spread toward towns like Grindavik. Evacuations and destroyed infrastructure confirmed a centuries-long eruptive cycle had restarted. Modern Icelanders, however, faced this ancient force armed with satellites, seismic monitoring, and real-time lava modeling. The Infrastructure Protection Group directs barrier construction, strategic road closures, and emergency responses, learning as eruptions unfold. Lava cannot always be stopped, but it can be guided. Iceland now experiments on a continental scale,